Example for understanding the Varignons principle. So the other example I am taking here as the two unlike parallel forces acting on a body simultaneously. So which affect these two rotate the body? There is a different case here, but here we need to understand how to apply the Varignons principle here. So to find out the unknown elements whenever we are solving the engineering problems. So I'm gonna take one body here, okay, AB as a body on which the two unlike parallel forces F1 and F2 both are acting in two opposite directions. Uh, unlike means which will be acting in two opposite directions. So F1 F2 are acting on a body AB in two different directions. So in this condition we need to apply the Varignons principle, in which we have to write the equation in a form as the resultant force, the moment of the resultant force about any particular point is equal to the sum of the moments of the number of forces acting on a body with a particular point we have considered. Okay, so here for that, so this is the resultant force which is acting away from the body at a point C. So why it is acting away means for two unlike parallel forces, whenever the two unlike parallel forces act on a body, so automatically the resultant force acts away from the body at a particular distance. Okay, so that distance we can find out if we know the magnitude of the forces and the distance between the two forces, and the distance of the point we are considering on the body with respect to the two forces. If we know all these elements, we can find out the distance of the resultant force which is acting away from the body in this condition. Okay, so for this I am considering a point O with respect to which we are going to find out the moment of the forces and moment of the resultant to apply the Varignons principle. So this is the point O. I am assuming from point O, d1 is the distance for the force F1 which is acting away from the point O, that is at your point A, and here again I am assuming the d2 as the distance between the point O and the force F2 which is acting at a point B, and similarly I want to assume the distance d from O to the resultant force R which is acting at a point C. Okay, these are the elements I am assuming, okay, for finding the moment of the forces. So now I want to apply the Varignons principle, which states moment of resultant force is equal to sum of the moments of system of forces. System of forces means number of forces acting on a body. Moments of sum of the moments of number of forces acting on a body. So here moment of resultant force means generally the moment formula is force into perpendicular distance to a particular point we are assuming here. So that is O here. So minus R into D. So the distance we have assumed D from point O. So with respect to point O, the moment of resultant force is minus R into D. Why it is minus R into D means clockwise movement. So which producing the clockwise movement. So with respect to point O, if you assume this point O as fixed point, so when the force is acting upward direction, so its effect is to produce the rotational moment in clockwise direction. So the clockwise direction we consider as a negative sign. Similarly we write the sum of the moments of the two forces F1 and F2. So the F1 also produces the clockwise moment, so that minus F1 into perpendicular distance from point O, that is D1 we have to write. So minus F1 into D1 is the moment of the force F1 with respect to the point O, and again another force is F2, so which produces again the clockwise movement. So again it is negative sign, so minus F2 into perpendicular distance, that is D2 from point O. Okay, so this is the way of writing the Varignons principle according to the forces, two unlike parallel forces, opposite forces acting on a body. So now while solving the engineering problems, if we want to find out any D2 element by knowing D1 and D, we can find out the D2 element. If you know the D1 and D2, we can find out the D element by knowing the F1, F2 and R. So likewise while solving the problems, we can easily understand how to apply the Varignons principle. So this is only the way of applying the Varignons principle to the system of forces acting on a body. Okay, this is the second case. So the resultant force, so by taking the negative as common, we can cancel the negative. So the moment of resultant force becomes equal to the moment of the force F1 plus moment of the force F2. Okay, so now the resultant we can write it as R is equal to F1 minus F2. Why it is F1 minus F2 means the upward force we consider it as a positive, the downward force we consider it as a negative. Y means upward, vertical means y direction, so the positive y direction and negative y direction. So that's why resultant is R is equal to F1 minus F2, two opposite directions. So automatically the resultant becomes the difference between the two forces. Okay, by knowing the resultant force, by knowing the magnitude of the forces, by knowing the two distances, we can find out the another distance. So like this we can solve the engineering problems. So in later classes we discuss the example problems on these kind of cases like parallel forces and unlike parallel forces by applying the Varignons principle. So I hope you understand a little concept of Varignons principle when we are considering the two unlike parallel forces. So once again, thanks for watching my video. Thank you all. If you have any doubts, please feel free to give a comment to my video. Then I'll try to clarify your doubts on engineering mechanics. Okay. So once again, thank you all.